And so this video for section 1.1. First thing we're going to talk about is the slope of a non-vertical line. And so basically the slope is just the change in y divided by the change in x. That's the same thing as delta y over delta x, which is just a change, which is the same thing as y2 minus y1 divided by x2 minus x1. And so this is a non-vertical line, obviously. And so let's go, I'm just going to go through some of the formulas here in this section real quick so we can make sure we have them all. So I'm going to move over to the next one. The next is slope-intercept form. And that is y is equal to mx plus b, where m is equal to slope, right? And then b is equal to the y-intercept. So remember the y-intercept, your x value is 0, and then whatever the value of the b is, that's your y-intercept. That's where the line, the graph, crosses the y-axis. The next one is point slope. Point slope form. So that's y minus y1 is equal to m times x minus x1. And that's the point slope. Of course, x1, y1 is the point, and of course m is the slope, just like the other ones. Next one that we have is the slope of horizontal line and vertical line. So if the equation is y is equal to k, where k is some real number, then the slope is equal to 0 because it's a horizontal line. There is no change. If that's x1, x2, this remains whatever x1, y1 is, so there's no change in that. If it's x is equal to k, again, k is some real number, then the slope is going to be 0. Let me write the k is equal to some real number. So k is an element of a real number. So the slope is undefined. The slope is undefined because it's a vertical line, so the value of x1 is always the same. So in other words, x1 is equal to x2, and so therefore it's going to be force you to divide by 0, which you can't. And if the slope is 0, then y1 is equal to y2. In other words, x1 minus x2 is equal to 0, and y1 minus y2 is equal to 0. So that's how you know those. There's also positive slope. Positive slope goes up. That means m is greater than 0. And if you have a negative slope, then the line goes down from left to right. And that just means m is equal to 0. So those are the 4 types of slopes that you're going to have when we're talking about linear functions. The next thing that we'll talk about is parallel lines, and then I'll go ahead and solve some of the problems. So parallel lines have the same slope. So 2 lines are parallel if and only if they have the same slope if they're both vertical. So in other words, if I have a line 1 and a line 2, and m1 is equal to m2, then these 2 lines are going to be parallel, right? Wherever that might be, that's L1, that's L2. The next one that they have here is perpendicular lines, I believe. So perpendicular lines, if I have L1 and L2, that means the slope of m1, or m1 times m2, is going to be equal to -1. Also, they're going to be reciprocals of each other. So if m1 is over 1, then m2 would be the negative reciprocal of that one. So they'll be equal to negative 1, if you will. So they'll just be opposite reciprocals, basically. So let's look at the first problem here. I think we covered all the formulas. We'll go back up to look at number 1. I'm just following the textbook here real quick. So number 1 is asking us to find the slope between these two lines. So I'm just going to label these here real quick, so it kind of makes life a little easier. So it's going to be 2 minus 5 over negative 1 minus 4. So that's going to be the slope, which is going to be negative 3 over negative 5, which is 3/5. So the slope here, right, 2 minus 5, y2 minus y1 over x2 minus x1. For number 3, the same thing. I'm going to label them x1, y1, x2, y2. So m is equal to negative 7 minus 4 over 8 minus 8, 11 over 0. So then this is going to be undefined. So one way that you can see that it's undefined is that you immediately can see that the x1 is equal to x2. And so that's going to give you an undefined slope. For number 5, if you remember, we said that if the equation is y is equal to k, some value k, actually this is a variable, so sorry. So in this case here, it's asking us for the slope. So if we think about the slope-intercept form, we can see here that m is equal to 1 and b is equal to 0. So the slope for number 5 is m is equal to 1. So if I were to graph number 5, the equation of number 5, it would go through the origin. So just a quick recap of that. So looking at number 9, if you remember, if x is equal to k, that means that m is undefined. And the reason it's undefined is because if we think of a vertical line, right, here you have y1, here you have y2, here you have y3, it never changes. And so that means that every time you move up, the x are equal to each other. So here is the slope is undefined. For number 8, right, y is equal to some value k, m is equal to 0, horizontal line, no matter what happens, your y never changes. All right, so x1, x2, x3, it never changes. For number 15, what they're asking us to do is to find an equation in slope-intercept form for each line. So slope-intercept form is y is equal to mx plus b. So there's 2 ways that you can do this one. First way is I'm just going to go ahead and plug in the values into the point slope. So it's going to be y minus 3 is equal to negative 2 times x minus 1. So negative 2x plus 2. I'm going to add the 3 to both sides. So it's going to be y is equal to negative 2x plus 5. So that's using the point slope form. I can also use the slope-intercept form. So it's going to be 3 is equal to negative 2 times 1 plus b. Add the 2 to both sides, and I get exactly the same answer, right? Y is equal to negative 2x plus 5. So there's 2 ways that you can do these. This one will take you to point slope automatically. So number 19, again, find the equation. So I have x1, y1, x2, y2. So I got to find the slope first. So 3 minus 2 over 1 minus 4. And so this is going to be negative 1/3. And so I'm going to just use this point right here. So I'm going to use 3 is equal to negative 1/3 times 1 plus b. So I'm going to add 1/3 to both sides, right? So then 3 is the same as 9 over 3, which is 10 over 3. So I just turned that into a fraction. And so the equation here becomes y is equal to negative 1/3 x plus 10 over 3. That's how you do number 19. For number 25, it says find the equation for each line in the form of ax plus by is equal to c, where a, b, and c are integers, and no common factors to o, and a is greater than or equal to 0, it says. So the x-intercept, the ordered pair would be -6, 0. The y-intercept would be 0, -3. So I'll do x1, y1, x2, y2. So MS equals to -3 over 0, 0 minus -6, -3 over 6 is -1/2. So, right, so -3 minus 0 is -3, 0 minus -6 is 0 plus 6, and 3 divided by, -3 divided by 6 is -1/2. So that's the slope. So the next thing we're going to do is I'm going to plug these in. So I'm going to say -3 is equal to -1/2 times 0 plus b, right? -3 is equal to b. So right now what I have is y is equal to -1/2 x minus 3. Since it has to be in the form of ax plus by is equal to c, I'm going to move the x term over to the left side, which is going to give me 1/2 x, 1/2 x plus y is equal to -3. Now, a, b, and c need to be integers. 1/2 is not an integer, so I multiply everything by 2. So I get x plus 2y is equal to -6. So the equation is x plus 2y is equal to -6 becomes your answer to number 25. So number 29, it's asking us to find the line of the equation through the point -4, 6, parallel to the equation 3x plus 2y is equal to 13. So there's two ways we're going to find the slope. We have to find the slope of this line. So the way that we normally do it is to solve for y, right? So -3 over 2x plus 13 over 2. So then our slope becomes -3 over 2. But here's the deal. If this is in standard form, I can actually use the following shortcut. I can say that m is equal to -a over b. So if you think about it here real quick, I'm going to show you why this will work. So if I subtract the ax from both sides and I divide both sides by b, I get my slope. That's my m right there. So it works every single time. So that means that you don't really have to solve for y. You can just go ahead and solve it that way. So then this becomes -3 over 2, which is the same thing that we got before. So it's parallel. So it's going to be 6 is equal to -3 over 2 times -4 plus b. So this is going to be 12 over 2 plus b, right? So -4 times -3 is a positive 12. And so b is equal to 0, right? So if I turn around and do it that way, I get that b is equal to 0. So then my equation becomes y is equal to -3 over 2x. And so if I were to plug in 4, I would get 6, right? So -4 times 3 over 2 is 6. 6 is equal to 6, so that's the true statement. So this is parallel right here, same slope. Perpendicular, again, so this is going to be, so in this case, my a is 1, my b is 1, so it's going to be -1 over 1, which is -1. So -4 is equal to -1 times 3 plus b, so -4 is equal to -3. So it's going to be -1 is equal to b. So it's going to be y is equal to -x minus 1. Now, it has to be in, so this one actually becomes -3 over 2. So let me finish this one here real quick, so I apologize. So 3 over 2x multiply everything by 2, so I get 3x plus 2y is equal to 0 would be the answer to that one. This one here, I'm just going to go ahead and move the x over to the other side, so this will be your final answer. All right, so number 61 is a word problem. This is what you're going to be seeing mainly on the midterm. So number 61 for A, it says the sales of a small company were 27,000 in the second year of operations, 63,000 in the fifth year. Let Y represent the sales in the X year, and then assume that the data can be approximated in a straight line. Find the slope of the sales line and give the equation. The line of Y is equal to mx plus b. So this is your x1, y1. Time is always the independent variable. So it's going to be 63,000 minus 27,000 over 5 minus 2. And so that's going to give you, I believe it's 12,000 when you divide it by. So it's going to be 36,000 over 3, which is 12,000. So that's our slope. So we're going to use this. We're going to use 27,000 is equal to 12,000, right? Times 2 plus b, which is 24,000. Subtract that, it's going to be 3,000. So the equation becomes y is equal to 12,000x plus 3,000. So that's how you do part A. Here's the equation. And then, so part B says use your answer from part A to find out how many years must pass before the sales surpass 100,000. So then it's going to be 100,000 is equal to 12,000x plus 3,000. All right, so that's the equation. We're solving for x. X is time. So this is going to be 97,000. So if I divide 97,000 by 12,000, and I'm going to go ahead and just write it as I'm going to go ahead and truncate this. So it's 8.08 years. So then if I do 0.08 times 12, I get about 8 years and 1 month before it surpasses 100,000. And then I'm going to leave you 62 for extra credit, and then I'll talk about that Monday, how to submit that. And that's the end of 1.1. Thank you.